Okay, this is homework problem number 17. So let's start right out on this. Let's see, what are we given? Okay, we're given all the points. So what we should list is points A, B, and C. Point A, point B, point C. Point A is going to be nothing x and negative 72y and nothing z. Point B is going to be going the x direction, negative 48, nothing y, and then negative 16z. And then for point C, it looks like it's going to be positive 24x, 0y, and negative 13c, or z. So now that we have the points, we can find the vectors of AB and AC. And it's going to be negative 48, negative 72, and negative 16, 24, negative 72, negative 13. And then, of course, then we can also find the, oh boy, lambda is going to have to be down here. So lambda AC and lambda AB, lambda AC. And all this is going to equal is a line, giant square root on the bottom. That's the basic form of it. And now all we do is we write on top of this the vector. AB is negative 48 I hat minus 72. Well, is j hat negative? If j hat's negative, then it would just be flat out 72. But I think I'll leave it as negative 72. So 72 j hat, and then this is going to be minus 16 k hat. And then the bottom is just going to be these numbers on the inside squared plus that's it, just like put a plus in between. And then same thing for AC. This one's going to be 24 I hat minus 72 j hat minus 13 k hat with 24 squared plus a negative 72 squared plus a negative 13 squared. And then all that you need to do from here is take just 48 and divide it by this whole thing, just 72, divide it by the whole thing. And that's going to give you your I hat, j hat, and a hat values for each of these. So what these are going to be is it's going to be negative 6 over 11 plus 9 over 11 minus 2 over 11. And then down here, 24 over 77 minus 72 over 77 minus 13 over 77. Well, plus. We're finally noticing that j hat is negative and negative negative is positive to my understanding. Okay, now that we have that, we can I would say probably do x. We can probably go to x and y variables now. We'd have to recognize first, however, that set the tensions. So tension in AC equals TAC lambda AC, and then you put the T on the outside. And we can also throw in our variables there. And yeah, since they're equal, this is gonna help out quite a bit. So tension in AB equal to tension AB lambda AB, which is going to turn into just the IJ and K hats. So all that is going to be it's going to be the negative 6 over 11 I hat plus 9 over 11 j hat. It's going to be that all over again. But what we could say here then is, and what I'll do is, if you can understand that concept, that all we would essentially be doing is rewriting all of this, but we would be going like this and putting T in front of it for TAB, TAC. If we know that it's one cable and these are the same, what we could say then is we have tension I hat, tension J hat, tension K hat. Just for this problem, but you'd have to remember too, I'll put an asterisk, that TAB and for TAC is equal to TAB lambda AB. But since we know this, what we can say is negative 6 over 11, because it's the same cable. We can add 24 over 77. Figure out what that equals. Same thing with j hat. 9 over 11 plus 72 over 77. Negative 2 over 11. 13 over 77. Looks like I'm getting negative 18 over 70. I'm not 17, 77. $135 over 77. And lastly, negative 27 over 77. And this is for the variable t. We also have, let's see, we have q, t, and w. And I don't think it says it here, but if I pull up the question, q is 54. So we know that q is 54. We do not know p, and we do not know w. And I think at this point now, we can set up our matrix by setting up our sum of x, sum of y, sum of z. So here, let's just see this. In our x direction, we've got negative 18 over 77. Y we have 135 over 77. Z, we've got negative 27 over 77. That's t. And then for p, it's going to be in the x direction, it's going to be 1. 1p because the variable is going in that direction, and then none of that variable is going to be in any other direction. And then for w, it's going to be nothing in the x direction. W is going to be negative 1 because it's going downwards. And it's going to be 0 in the z direction. We have xyz, dpw, and this is going to be equal to second vector q is going to have xyz, dw, xyz. We know the force q is in the z direction, positively going 54. We don't know the y direction. We don't know the x direction. When we plug this in, variables here, left to right, go top to bottom. dpw. So what we should get is our answers here. T, oh, I'll do this. This should be T, T, and W. This vector here is going to be X, Y, and Z. Okay. So if I make this matrix now in the calculator, it's going to be a 3 by 3, I believe. And the first one is negative 18, 77. Second one is 1. Third one is 0. We have 135 over 77. Next one's 0, minus 1. The last one is negative 27 over 77. Followed up with 2 zeros. Go to matrix, do the next vector. This one's a 3 by 1. It's going to be 0, 0, and 54. Now if I add my calculator, matrix A, put it to the -1, so it's the inverse of that, and I multiply it by vector B, I am getting -154, -36, -270. It looks like Z should be -54. Aha, I know why. Because the Z direction is going to look like this. Some of the forces in Z equal -27 over 77 for those variables, right? TPW, Q is not a variable. I didn't even think about it. There's going to be 0P, 0W, but there's also going to be a positive 54 equals 0. And what you also don't see is secretly, that's T. There is a variable T added to this because it's tension. All of these have a variable T in front of them from this. Ti equals this I, so it's Ti hat this. However, 54 doesn't. So what we do is we move 54 from here to the other side. So then this whole equation then becomes equals -54. So in reality, if I get the eraser out, my mistake, these are all positive values. And there you go, that is how you do this problem.